In part two of this video series, I'm still going through the solutions for this second formative about functions. And I'm going to skip down to the bottom here, number 3. And we're given a function, g of x equal x squared minus 1, and we're asked to evaluate this function at various values of x. And it's worth just reminding everybody that it's a little bit unfortunate that we kind of overuse parentheses in mathematics. Parentheses in arithmetic help us force operations to go out of order. It's a way that we group operations. Parentheses up here in this problem, we used in two different ways. We used them to denote our ordered pairs when we're describing points, but we also use parentheses in when we describe intervals, like when I describe this domain. And then another way that we use parentheses in math is we describe functions and their inputs using parentheses. So when I see this, sometimes, and when students are brand new to functions, they look at this and they say, oh, it's g times x. And surely, of course, you would think that when you've done so much work with parentheses and arithmetic. But we say g of x, and what we're saying is there's a function named g, and it takes an input of x. And that's what that means. And then when I put this equals x squared minus 1, what I'm really doing here is I'm describing the rule that the function g applies to its input. In other words, the function g squares its input and then subtracts 1 from that square, and then that's how you produce the output of this function. So even though there's no y in this equation right here, we could really say that once you evaluate this function at a particular value of x, that's how you get y. That's the output of the function. So again, that's one of the things that we kind of get hung up on when we first start learning about functions is the way that we write all these different things. But just keep in mind that really what a function is, it's a relationship between a collection of inputs and a collection of outputs. And that's an important thing to keep in mind. So let's do some of this now. If I'm told this rule, g of x equals x squared minus 1, and then I'm asked for g of 2, all I'm going to do is really this. I leave a little blank space in my formula here, in my expression where the x was, and whatever's in here, I'm just going to put here, like that. So this is 2 squared minus 1, which of course is just 3. Going down to this one here, right? It's the same idea. Got to be careful with your negatives, of course. Let me do it in the same way. I'm going to have a set of parentheses here. Whatever my input is, I'm going to put there. I'm going to square it, and then I'm going to subtract 1. Well, my input is negative 4. Notice that if I do it this way, I end up squaring not just the 4, but the negative, of course, because the negative is part of the number that I'm squaring. It's not separate from the number. And that gives me 16 minus 1, which is 15. Okay, and so you got to mind your signs, especially when we're squaring stuff. Once again, g of a. Well, there's my input right there. I'm going to square it and then subtract 1, and it's just an a. So I can maybe simplify this a little bit by getting rid of those parentheses, and that's how I like to write it. Okay, and I'm just going to continue with this pattern. G of a plus 1. Well, I need a little more space now for my input. I'm going to square it and then subtract 1. Well, it's a plus 1 in there. And we are asked, I could leave it like this, I suppose, and maybe that's useful if I want to understand something about vertex form and all that kind of stuff. But that's really not what this question's about. This question did tell us to find this in simplest form. And one of the things, when we simplify expressions, we're going to combine like terms. And you may notice that there's if we multiply this out, in other words, if we square a plus 1 squared is going to be a squared plus 2a plus 1, and then I'm going to subtract 1, this one, and I'm left with the a squared plus 2a. And that is simplest form. So frequently, when we're talking about quadratics in simplest form, you're pretty safe to write it in terms in standard form, ax squared plus bx plus c, or whatever your variable might end up being. Here, g of a squared, again, I'm going to take my input, square it, and then subtract 1. And my input in this case is a squared. Well, a squared to the second power, that's a squared times a squared. That's a to the 4th minus 1. And finally, this one here, g of a squared plus 2. There's a little more work that goes into this one, but let's just do it in the same way. I'm going to take my input, square it, and then subtract 1. And my input is a squared plus 2. And maybe some of you will be able to look at this and be able to write it out just as I did here with this perfect square, a plus 1 squared. But, if you need to write it out like a squared plus 2 times a squared plus 2 minus 1, that's important because notice when you do it this way and you start using the distributive property, you're going to get a squared plus 2a squared plus 2a squared. I'm sorry, this is going to be a to the 4th. That's what I get when I multiply these two terms. And then I'm going to end up with a 2a squared and another 2a squared. That makes 4a squared plus 4 minus 1. And then finally I can simplify that. A to the 4th plus 4a squared plus 3. And so when I evaluate the function g with this expression, right, I really do need to use the distributive property. Some students are still making the mistake of looking at this thing and just coming up with a to the 4th plus 4. And that's a to the 4th plus 4. But you miss this middle term if you don't properly multiply a squared plus 2 times a squared plus 2. So just think about that and be careful. We can't distribute this exponent over this addition. And that is a very common mistake by math students. So if you need to write it out, do that intermediate step and make sure that you don't make that mistake.